Hello, good afternoon. Huh? Right? Well, good afternoon and welcome to this Tech Talk. My name is Ada Wu and I am a team member of ACT Next, and it is my pleasure to introduce Dr. Shea Brown today. Dr. Brown is the founder and CEO of BABL AI, a research consultancy that focuses on ethical use of AI and machine learning algorithm. And then in his other day job, he is a faculty member at the Department of Physics and Astronomy at the University of Iowa, where he leads an astrophysics research group that applies modern machine learning techniques to large astrophysical survey to study the evolving universe. Dr. Brown is an active member of the International Square Kilometer Array Community, SKA, and where he gets lots and lots of data to work with his students on this analysis. And one fun fact about Shea is that before he became an astrophysicist, he was a lumberjack. So if you need to buy a new chainsaw, he will have good recommendation for you.
Yeah.
Welcome.
All right, thank you very much. I do miss being a lumberjack sometimes, especially the long days in the classroom. All right, well, thank you so much for having me here. This is a pleasure, and it's a wonderful campus, and it's nice to meet everybody and to hear the exciting things that you're doing. So this is a tech talk, and so I will be talking about technical issues, although it's going to start very broad, and I'll start zooming in towards the end. So those who want to take a nap can wait until later. BABL AI. So that here it says ethical algorithms, and this is the Tower of Babel. What I'm going to be talking about today is a really specific thing, exploring cultural bias in natural language processing, and I'm really going to be exploring because this to cover this field. Which has exploded really only in the past couple of years, and just in the past few months, it's seen exponential growth, would take many hours. And so what I'm going to do is I'm really going to play around with it and just give you a flavor for where some of these biases come from, where they can come from, and how they could affect people who interact with these algorithms. But I want to start out with the sort of the big picture, because there's going to be a lot of doom and gloom in here. Not a lot, but there's going to be some what might sound like cynical talk. And there's a lot out there now regarding AI and how AI is being used, either properly or perceived improper use of AI. But I want to point out that I'm an optimist. I really am. So our mission statement really is recognizing the fact that the world is going to be driven by algorithms. Anybody who works in artificial intelligence now, or even has a secondary contact with the field, I think knows that algorithms are already part of our lives, everyday lives, and it's going to become even more so. And when you start talking about things like the Internet of Things and how connected our cities, our workplaces, our schools are going to be, we know that there are going to be algorithms working on our data every day and every minute of the day. And so what we really try to do, what our mission statement is to make sure that these algorithms, to strive towards making these algorithms fair, effective, transparent when they need to be transparent, and really tethered in human values, real human values. And now is the time to start this. And there's a real movement. And we're at a tipping point now where people are starting to realize this. But there is also a danger that too much of the press that's coming out could stigmatize artificial intelligence. And we don't want that. Those of us who know the power for making a more egalitarian society. And so our vision, this is what we want. This is what I think all of us want, this picture of a future where everything is connected. We can find the right solutions quickly for problems. And there are a lot of problems. This is the utopia that we'd like. These smart cities is just one aspect of it, where we can use big data, we can use artificial intelligence to find real solutions in real time for all of the problems that we face as a society. And there are a lot of problems. And here's sort of a very nice graphic from the United Nations. These are the Sustainable Development Goals for the United Nations. And this, when I saw this was a real turning point for me. I sort of found my own mission, what I care about, because I realized that for all of these, every single one of these goals, and a lot of which ACT really is contributing to solutions and working towards these goals, all of these can benefit from AI, okay? All of them can. And the question is, can we do this in a timely manner? Fast enough that we can actually have an impact for our kids. And there are also a lot of goals here where AI can be very, very destructive if used incorrectly. And so we also want to strive that we do this carefully and that we understand the implications for when we deploy these algorithms and when we use data that is important to people. So there's an alternate vision of a dystopia. And I think a lot of what the media currently is focusing on is the possible dystopia that could result. And this is just an image of an AI startup in China right now working on facial recognitions. And I'm not going to pick on China here because this is happening in the US, this is happening all around the world. It's just that it's facilitated by the infrastructure in China to make this transition a lot faster than it's going to happen in the United States. And there's lots of possible implications for this ability to track people in real time. This is an image of facial recognition being used to out jaywalkers in public, and not just outing them, but outing their ID. Who this person actually is. And we do this in America. You go to Iowa City Press Citizen, and you have the mugshots of people who haven't been convicted of any crimes, right? They've been arrested and accused of a crime, but their faces are there. And so this idea of a social credit score, which is being bounced around and even implemented in some places in China, where you can actually get scored. If you don't pay your loans, you have this social credit score where essentially you start with a certain number of points, and points get taken away if you are late on your rent, or you don't pay your loans, or you jaywalk. And if you do nice things, the score goes up. And this is already affecting people. A score that's very much like this, it hasn't been automated to scale. The score very much like this is already affecting people. They're not getting loans that they might get because there's so much surveillance and there's so much information being kept. And that information gets compiled in ways that nobody has access to. And this is the dystopia that I also don't want to see happen. I'm an optimist. I want the utopia. And so we're at a tipping point now where the technology is moving fast enough that we have to worry about this. And this slide, nobody's going to be able to see. There's too much here, okay? But the AI Now Institute, which is a wonderful institute, nonprofit institute in New York, is tracking AI, tracking the uses of AI, both in the United States and abroad. And they're keeping track of how it's being used, what are the problems. Mostly what they're keeping track of are the scandals, okay? And maybe gaffes are a better word for some of these. A few of them, like Amazon coming out with their recognition, facial recognition system. This is not a gaffe, this is just an event that happened. But then, it gets used for a variety of things. The ACLU used it to match a bunch of congressional faces with known criminals, right? Now, of course, the way it worked is that people who work with machine learning know that they set the threshold to something like 85% accuracy before they can do this, okay? But that doesn't necessarily come through. And because I'm an optimist, what BABL is trying to do and what we're really aiming for is to clarify these issues for the public and to facilitate people who are working in the field and people who are interrogating the field, biased detectives, actual reporters, people who are going out and looking for these gaffes. And we want to try to clearly define all of these issues so we know what's a serious thing and what's not so serious or something that we can overcome. So this came from the annual report. This is all in 2008. Self-driving Uber car kills a pedestrian. We have lots of problems where employees are revolting against their companies, saying don't do this contract with ICE, don't do this contract with the Department of Defense for autonomous weapons. And so there are a lot of issues. One issue is bias in these algorithms, okay? And so most of what we saw there was misuse of the algorithms. It's not about the algorithms themselves. The algorithms probably work fine, but they were being misused. So what about actual problems with the algorithms? So how much damage could that really do? How much damage could bias do in an algorithm? That's the question, because maybe not much. We have to investigate this. So we can look for historical analogs. So this is a pun, because it's really sort of an analog algorithm that we're going to look at. And this is just a one slider here, and so I'll do lots of talking and just leave this up. But the Federal Housing Authority had an algorithm in the 1930s. And it was a real algorithm. It's actually not analog, it was digital. There was a rubric, and it's very much the kind of thing that ACT would be familiar with. You know, you have a rubric, somebody comes in, they want a loan, we want to figure out whether the FHA should insure this loan, it should be accepted. And so they have an algorithm where you will score both the property and the people, the borrower, and they have a rubric. And it turns out that a lot of what they had in this rubric was biased against, well, by proxy, mostly poor African Americans in urban areas. And a lot of it didn't seem like it would be biased. It really was, these were proxies for people living in inner cities. They didn't, you know, on the face of things, it wasn't racially biased. You know, you wanted, you know, to ensure houses that had a lot of open air, a lot of open space. And so if you had an apartment block in an inner city, that was not the kind of place that FHA wanted to insure. So there were some that were actually explicit, where mixing of races in a neighborhood was a bad thing. That actually counted against it, because there could be some sort of conflict. And so developers would actually go out and into the suburbs, and they would produce segregated neighborhoods. And in fact, you even got scored higher if you had barriers, physical barriers between neighborhoods. If it was very clear, it was difficult to get from one type of neighborhood to another. And so what were the implications of this? This was caught, by the way. I mean, it didn't last forever. Around 1948, I think they figured out that this was not constitutional, and it stopped. But unfortunately, by then, segregation had increased by 40% from 1910 to the late 1940s. And it continued to go after that. It didn't stop. And the reason was because people who were in the inner cities, they could no longer afford these very nice houses in the suburbs. And in fact, schools are more segregated now than they were, I mean, in the 1960s. Income inequality, racial income inequality is greater now than it was in the 1960s. These are things that are difficult to repair. And so the question, my motivation for studying this really is, how do we, with this sort of knowledge, what kind of foresight can we have for how we deploy these sorts of algorithms that may contain bias that we don't detect? How can we predict what might happen and try to keep it from happening? Because it's very difficult, even after it's been stopped, to go back and fix what we've done. So again, I said there was going to be some doom and gloom, but I'm an optimist here, so bear with me. So this is happening a lot. This is just a recent article. Amazon scrapped secret AI recruiting tool that showed bias against women. And so I'm going to show you exactly sort of where this bias, this type of bias comes from in natural language processing. But you know, this was reported just recently by Reuters, and the problem is this is a gaffe, right? It's more than a gaffe. This is a real scandal, but it's really only a gaffe in the sense that Amazon didn't actually use this algorithm to really make decisions about hiring people, or at least this is what they say. And they also caught it and they fixed it, okay? And this is encouraging. When I saw this, I was actually encouraged that, and there's gonna be a Google example coming up later. People are worried about this, and this is a good sign that this was caught. But then this comes out in the news and it looks really bad. But I think that this is encouraging that they are actually aware of the issue. They found it, they couldn't fix it, and they scrapped it. Okay? And this is something that I think is encouraging. So where did it come from? Well, basically it came from the training data that they used. The source of the bias is in the training data that they use. They basically, Amazon's been around for a while. They've hired a lot of people. They have a lot of CVs, right? And if you look at the sort of breakup of male versus female over a bunch of tech companies, you can see that they're doing okay, I guess, but they're definitely not doing okay in the tech field, okay? And Amazon, by the way, didn't comment on how many females they had in tech positions. But in any case, the numbers are bad, okay? And so what happened is that the training data, they took all of the CVs of high-performing employees, and they looked at, in a very sort of unsupervised way, which is how it happens with natural language processing, and they just took the features that correlates with a highly performing employee. Most of them happen to be men. The systems learn to recognize male hobbies, for instance. There are reports that typical female kinds of hobbies were penalized with the algorithm after the fact they figured this out, of course. And even all women colleges, in one case there was 2 all-women colleges which they didn't comment on which ones, which actually, if that showed up in your CV, it was downgraded in the algorithm. Now this happens because the way algorithms work nowadays is that they're black boxes. You know, we have smart algorithms, they're neural networks most of the time, and they learn features that correlate with whatever it is you're trying to predict. And unless we have a way of figuring out what those features are, this sort of thing happens. And luckily Amazon, people working at Amazon were smart enough to eventually figure this out. So that this didn't turn out like the FHA example. However, I mean, human bias in recruiting probably helped create this, right? And so that's what they were trying to avoid. And this is also going to be very difficult, as you know, to overcome in our generation. So we're working on it. But now let's focus on natural language processing. Okay, let's get a little bit more technical. So the spoiler alert here is it's just bias in our natural language. Okay, it has nothing to do really with how we're training the algorithms. It just comes from the fact that we have biased language. The language that we use and that we record have biases within it. In fact, we count on that as machine learning engineers. We count on the fact that it's biased. What we want to avoid is unwanted bias. So this is going to be very high level here. What is natural language processing, NLP? We use it for a variety of things. Basically, what you do is you take natural language. It could be voice, it could be text, written text. You put it into some sort of black box or some sort of machine, and you get things out of it. You get information. And the kind of information you can get is you can search for documents that are similar to the document that you put in. You can translate between languages. Okay, this is something that clearly is extremely useful. Sentiment analysis, which is what I'll be focusing on later, where you want to know in a movie review, for instance, can you automatically detect whether this person hated the Hulk or they liked the Hulk or whatever movie you want to use. Can you do this? And this is this is not just a large field, this is also a lucrative field for businesses. You know, who's talking about us and what are they saying? Is it good or bad? Information extraction. This is probably where a lot of work at ACT comes in. I get information from students in the form of free text. I want to extract some information from that, and that will go feed into some models of how well they're doing in their various skills that I'm trying to assess. And there's question and answering. This has become a huge field now because it's expensive to have humans help other humans on the internet, and so you have a chat box do it. So can you answer typical questions and with high accuracy? And this is another sort of lucrative field and that's exploding right now. Okay, so one piece, the very first piece you have to figure out is words are not numbers, and we need numbers to have the computers do what they do. And so the first step really is to map the words into some form of number. Okay, we call this tokenization. So corpus is the group of texts that you're going to be analyzing, or a very large group of texts that you're going to be training on. And so what you want to do is take every word, or the most frequent words in that corpus, and map them to some numbers. So one way of doing it, of course, is to just have a very long vector or a very long array, where if this is Rome, so if I have a 1 here, that means that this is Rome. If I have a 1 here, then this is Paris. This is one hot encoding, they call it. But you need a vector that's as large as the number of words in your corpus, okay? Which can be a problem if you're using, let's say, the entire World Wide Web or something like that, okay? So this is very inefficient. And the other thing that it doesn't capture is relationships between words. I know that cat and kitty are used in very similar places. They mean very similar things. And so, but if I look on this list, they may not appear anywhere near each other. In fact, the nearness on the list doesn't really mean anything anyway. So we would like to come up with some way in which we can represent words that capture some of this, okay? And that's where word embeddings come in, where essentially you map these words, each word, into a larger dimensional vector space, essentially. So imagine a big vector, and this represents cat, okay? So let's say it's 3-dimensional, right? So I have 3 different dimensions. And if I were to map the same vector for kitty, what I'd want is it to be very close in that vector space. So the nearness in vector space is going to imply that they have similar meaning, or they're used in similar contexts, which tend to be, so you can kind of equate those two often. And that things that are far away mean that they're unrelated. And this has been a very powerful idea. So essentially what you're doing, not only is that useful in terms of capturing information, it's also easier to compute, because instead of having a bunch of very long vectors, so what this is representing in color basically is what these things over here are, is that this is one word, this is very sparse, very high dimensional. I can have a lower dimensional thing which actually captures these information. Yeah. So most natural language processing nowadays starts with mapping words into these higher dimensional vector spaces. And there's different ways of doing it. And this is starting to slowly creep into the tech part. I'll pull back out again in a minute. There's different ways of doing it for those of you who do machine learning. You have continuous bag of words, where essentially what you do is you have some word. I pick a word like kitty, and then I say, can I predict what that word is based on the words that are around it, its environment? Because kitty and cat probably will show up in similar kinds of environments. And so if I can make that mapping, if I can predict it, then the representation which I used to make that prediction is what this embedding is. It captures that information that they're used in similar contexts. And you can use what is called a skipgram, which just reverses it. This turns out oftentimes to be a little bit easier computationally, where you have the word and then you predict words that would be nearby it. Okay, you're just reversing it. Give me the word cat, and I bet that I'm going to see the word pet or purr or something like that over here. And what you do is you just take lots and lots of data, and you you basically produce these embeddings. So it's trained on a very large corpus of text in an unsupervised way. So unsupervised means you don't look in particular, you don't label anything. You don't say that I expect to see her near the word kitty. You just let the data do it. You just chunk up the data and let it do it in an unsupervised way. But it works really well. And what's nice is that relationships are captured also in these vectors. So for instance, there's a male-female relationship, which we're going to get back to. You can already see problematic things happening. But, you know, king, the arrow that goes from king to queen in this weird vector space is the same arrow. I could just move that arrow over. It's the same arrow that goes from man to woman. Okay, that makes sense. And that's encouraging that that kind of mapping is held. Walking, the arrow that goes from walking to walked is the same as swimming to swam. Right? It's capturing our language. It's encoding how we use our language. And, you know, capitals of countries, those sorts of relationships are captured. So already we have this powerful tool to represent words that captures these meanings. And typically we do this, and then we do something else with the words afterwards, and it makes it a lot easier. However, some people have noticed that there are problems with this. And it's not problems with the method, but it's problems in our language that they're capturing. So for instance, man is the computer programmer as woman is the homemaker. This is the title of the paper. And the question mark, of course, right? So this is basically what they examined was word2vec. Word2vec is a particular type of embedding. And they used a corpus of Google News. Okay, this is news written by presumably educated reporters, right? And they use this as a corpus of text and they learned these word embeddings. And what they found is that there are lots of stereotypes, okay? He, she analogs, sewing is the you know, so if you take the vector that goes from she to he and you attach that to sewing, it points you to carpentry. If you attach it to nurse, it points over to surgeon. Blonde, burly, so on and so forth. Hairdresser to barber, that one might make sense. Gender appropriate he, she analogs. These are ones that would make sense. Queen is the king, waitress is the waiter, mother is the father, okay? So it gets it right, but it also encodes these built-in biases that we've been struggling with for a long time. And nowadays, it's really coming to the forefront that this is just not okay. Extreme she occupations, you know, so there are certain occupations which have a extreme female context. You can see them here. Extreme he occupations, right? This is clearly 1950s stuff, okay? And this is from Google News, right? This is taken from recent, it's not like they're going back to the 1930s, 1940s, or 50s. To get that this is a language that is being used in the modern internet era, okay? Now, the interesting thing about this is that this shows up despite this idea of reporting bias. So reporting bias is the bias where things that are just obvious go unsaid. So what that means is things like male nurse actually shows up more often in our language than female nurse. You typically don't say, oh, the person working with me was a female nurse. You'd say it was a nurse. And if it happened to be a male, you'd say a male nurse. I mean, you wouldn't, but it does get said. So even though there's reporting bias, you see male nurse a lot more often. These algorithms were smart enough, this process was smart enough to figure out that what we really mean is that nurses are females and surgeons are males, okay? So it's amazing that that happened and scary at the same time. This is what's beautiful about this. You know, this is why I think this is actually really good. This is uncovering things that should be uncovered in our own language. This is not something that should be unsaid. We're digging things up, and this is a exorcism, so to speak. So let's look at a case study in sentiment analysis. So, you know, I'm interested in algorithm auditing. Now, auditing is a bad word, and I've been told by my consultants that I shouldn't be using the term audit, so I won't. Well, I am. But what I'm really interested in doing is how do we evaluate algorithms? Because a lot of what's happening so far is that what people are doing, people meaning reporters and so-called sort of bias hunters, right? Me, I guess I'm one of them. What they're doing essentially is digging up these gaffes, digging up these things, and it gets thrown out there and people see it, but it's not put into context. And what I think is important is we need to put these algorithms in context. How are they being used? Who do they affect? What are the issues that all of the stakeholders have? You know, rights, you know, issues about privacy, intellectual property, voting rights, all of these various things that different stakeholders have. We need to put these algorithms in context. How do they threaten them? And so when we analyze it, it has to be balanced. And so, which is why I'm interested in coming up with a framework where we can actually do this. I'm not going to go through that framework now because that's not what we're talking about. But what I'm going to talk about came as a result of a case study that we're doing. So in our company, what we do is we're working on our method for analyzing algorithms. And we have a framework which is centered around sort of 3 pillars of a good algorithm, I think. Transparency, effectiveness, and fairness. Okay? And there are subcategories here, and I'll show you in a second what they are. And so we've been posing various case studies based on people that companies that we've talked with and various groups. And one is, in particular, that we've done recently, we're still in the midst of doing it, is an online university using natural language processing to sort student comments. Not student, yes, student comments, but about instructors. So this is not part of the regular, this is the end of the term. So you have a very large online university. There are, at the end of each term, the students are writing free text comments about their instructors. And this is because it's an online university, the instructors are sort of term by term contracts. And there's a heavy emphasis on keeping good instructors and getting rid of the bad ones. And so these comments are, there's over 10,000 of them. So the HR department wants to have some way, because there's only one person and one intern in the HR department, they need to sort through these in a way that makes sense. So you can use sentiment analysis. And what they do is they say, okay, we just go through and look at all of the comments, and it's going to be either positive or negative sentiment. We're going to take the top 10, the best ones, the best comments, and we're going to stick them, and then the top, bottom, we want to see what bad things people are saying too. We put this in their file so that we can look at it later. HR can look at it later, and the head of the school can look at it later. And then also, because we can, and we're drunk with power with machine learning, we're going to take the average sentiment score for each professor, and then we'll stick it also in their file, because that might be a useful metric, okay? And so in the context of our case study, we are analyzing this and putting it in context of, who is affected by this algorithm and how are they affected. But in the process of it, we had to come up with the algorithm. Oh, here's a little sneak peek at how we actually do it. This is, we actually come up with numerical scores for these. And we do something very similar probably to what ACT does. We have rubrics, we have various subcategories: societal bias, statistical bias, infringement of rights, potential for abuse of algorithms, transparency of architecture, meaning is it a neural network or is it just an equation or some rule-based system? Transparency of use, do people know it's being used? Do students know it's being used? Do the instructors realize that's what the number is? It's automatically generated. Transparency of data use and collection. Do people know what data is being collected about them and how it's used? Effectiveness, congruence with purpose, right? You have a purpose for an algorithm. Does the algorithm actually do what it says it's supposed to be doing? Or is it sort of tangential or just a bell and whistle that doesn't really do anything? How accurate is it? This is probably something we're more familiar with here as machine learning engineers. Stability and repeatability. Do I get the same answer with the same inputs, right? Not all algorithms do. Efficiency of data use. Could you have neglected the sneaker size and still got the same answer? Or the zip code. Did you need to take the person's zip code to do this? Okay, how efficient are you being with the data? In any case, this is what we do, and all of this is weighted by stakeholder interest, right? Because not all of these are relevant. So it is, as an example, your interest in privacy, right? Your interest in privacy, let's say, yeah, I have a camera in my room, and I'm an elderly person, and the camera is going to see if I fall, and it's going to notify somebody that I fell, right? We have necklaces that will do this probably more efficiently than machine learning, but whatever. Just imagine for a second. So one thing, major interest in this context is interest in privacy, right? It matters whether the camera's in my bathroom, let's say, and it's watching me while I'm taking a shower, or if it's in my living room, okay? So that's a contextual difference, right? But not that interest of a person, interest in privacy, doesn't map one-to-one with all of these different subcategories, right? Transparency of architecture. Doesn't matter whether it's a neural network or if it's some kind of rule-based system. Does my right to privacy have interested in that? The answer is probably not, right? But I might be more worried about the effectiveness, how accurate it is. Is it going to go off when I bend down to pick up my soap, right? Is it going to notify the police? I didn't fall, I just picked up my soap. So this is a sneak peek at how our method works and trying to contextualize what's actually important and what we should be focusing on. But in the process, for this case study, we actually had to make our own algorithm in order to do this. And so we used a neural network, okay? So the way it worked basically is we had pre-trained word embeddings. In this case, we used what's called the glove word embeddings, and you can see the link there. And unlike the one that, the word Tvec, which used the Google News, this network, these word embeddings were trained on the web, the Common Crawl. They took data from the web and made these word embeddings. And then we used a gold standard sentiment lexicon. So what that means is somebody went and then somebody, references there, and said these are good words. These are words that are positive sentiment, strong, good, nice, and these are ones that show negative sentiment. Okay, and so they come up with this lexicon, and essentially what we did is we trained a network, a very basic network, to detect with from the embedding, can I predict a good word versus a bad word? That was our training data. And so then when we, for the sentiment analysis, what we essentially did is we have a sentence here, and we take the word embeddings for each word, we average them, and then we run it through that network, okay? And what we get out at the end is a sentiment score that says, was this positive or negative sentiment? It's a very basic thing. This is a variant of what's called deep, a DAN, a deep additive network. But in any case, we wrote that, and it worked pretty well, okay? So I'm not gonna show you lots of tests here. Let's just play around with it, okay? Because I don't want people falling asleep. So this is from a Python notebook, if you're curious, and I took some of these sentences from Robin Spear. So this example is pretty cool. And what I get is a sentiment of 3.65, okay, ... Pretty positive. This example is okay. It's a little bit lower than this, okay, so the normalization is a little bit weird. This example sucks. All right, I got a negative sentiment. So far it's working all right. Okay, so far it seems like I'm doing okay. This is not a rigorous test by any means. Let's do it for some food. Let's go get some Italian food, okay? Yeah, we all like Italian food. This is pretty positive. Let's go get some Chinese food. A little bit less. Let's get some Mexican food. Clearly this is not an American because that would be much, much higher, okay? So something funny is going on because none of these words are different. The only difference is Italian, Chinese, and Mexican. Sentiment is changing, okay? These should be these are neutral statements, right? And these terms here were just plugged in and shouldn't have anything to do with the sentiment of that statement. But things are changing, okay? So if we go back to our sort of metrics that I was looking at, the stability and repeatability is already questionable. And we're already starting to see some sort of bias going on, societal bias, something in the language. How about if we look male versus female? This is, put more of them in here. Man, if I just throw man in there as a word, it's negative. It's a negative sentiment, but the normalization was a little messed up. So let's worry about relative. Woman, right? These two things should not be, should not have any normative value. Father, mother. Here's a weird one. Maternity leave, paternity leave, right? The guys were getting it pretty good up until now. All of a sudden it switched. That's creepy, okay? But it's weird. This is the exorcism, right? This is exposing the bias in our language. It's okay for a mother to take maternity leave, but the guy, come on, get back to work, right? Something is going on here. It's capturing bias in our own language. Now let's talk about race a little bit. John versus Jerome. Donna versus Tanisha. Okay. Yeah.
Was the training data for all these the comments from the students?
No, that's a good point. It was not. In fact, this is the algorithm itself. So the training data came from two places. One was the entire web. That training data was used to construct these embeddings, that vector space that captures relationships between words, right? That was done and pre-computed by some researchers, similar to Google did Word2Vec. Then what we did is we took positive and negative words that were, somebody else decided that good is a positive word and bad is a negative word, right? That kind of thing. That's the lexicon. And we trained a network we took those good and bad words, projected them into this vector space that was created before, and so that now there are these embedding vectors. And then what we did is we trained a very simple classifier to predict what's a good word and what's a bad word. Now, because nearby words have similar meaning in vector space, we can apply this same network. So bad and badness, let's say, two words that are very nearby. Because they're similar in that vector space, my classifier works on both of them. Yeah, and so the relationships get captured in that way. I mean, it's not an ideal thing. It's not an ideal thing, but it's the way people do things now. Okay? And so this is capturing those relationships in how close is Tanisha in that vector space that we got from the web to negative sentiment. And Tanisha is closer than Donna. And Jerome is closer to negative sentiment than John in that vector space. That's really what this is mapping. And so we can go a little bit further, and I won't get into the details. What you can do is you can take a bunch of names that are associated commonly with different ethnicities, and that's exactly what we did. And you can see, this is the sentiments, this is a box diagram. This is the sentiment score versus the group, okay? And you can see that if you include all of them, it's not so obvious that there's a lot of overlap, right? There's plenty of cases where you know, a common Hispanic name is going to be better than a typical white name. But on average, if you take them as a statistical sample, it's skewed. It's skewed. And those of you who know statistics, the F statistic is like 15 in this case. Oh. Okay. Okay. So my the first piece of advice for fixing this is basically use better data. In fact, it turns out there's some recent work coming out of MIT that's really, that's the primary way to do it, is fix the data, okay? Don't bad in, bad out, so to speak. And there's lots of mitigation algorithms that people are using, but this is the best one. Just don't put that crap in. So there are people who are working on having better word embeddings. So this concept net have this number batch word embedding where they've actually looked at the bias and they've tried to mitigate for this using some standard techniques. They've tried to fix these common biases in our language. And now if you do that, here's a comparison, correlation with stereotypes. The purple is where they are. So they do very well on gender, okay? Not so well on some of these other ones, but better than some of the typical ones. The ones that we used for our case study was this glove here. Yes, it was the orange one. So it's one of the worst ones. So being a little bit unfair. So as not to be unfair, for our case study, we actually used the good one. We used the number batch because we figured hopefully the vendor who created this algorithm would be smart enough to realize that this is an issue and they would have used a better. And you can see that things do get better. Man versus woman, okay? There's still a difference. Father versus mother, right? Not as much of a difference. Maternity leave and paternity leave, okay? And if you look at the box diagram, it's smoothed out a little bit, okay? So there are ways of fixing this. There are ways of, I wouldn't say fixing this, there are ways of mitigating this. And that's really what we're striving for. So this field in general, like I said, is really exploding. And as a person whose primary job now is to keep up with the literature and the current state of the art, it's very, very difficult. And it takes an extreme feat of organization on my part to sort through all of the literature because it's coming out very quickly. A few things to keep in mind when we're talking about these issues is that there are lots of different issues to consider. So for instance, when we're talking about fairness in an algorithm, there's a difference between individual versus group fairness, okay? Individual fairness says that we treat similar individuals the same way, okay? And so that we don't, on an individual basis, we don't discriminate. And group fairness says between groups, we want to treat them the same. So those are two different ways of looking at it. There's also worldviews, okay? There are different worldviews. And there's a lot of complexities about how these are cast, but one is that we're all equal. So what that means is, intrinsically, we are all equal, and the data that we're getting, it might be, if we're talking about metrics that we're using for how we're evaluating students, the idea for we're all equal worldview is that there is no difference intrinsically between groups, and that if we're seeing differences in the way what we're measuring, it's because the metrics that we are using are skewed. They're not mapping directly onto the space where these concepts really lie. Okay? And then there's what you see is what you get, which is a little bit different. And what they're saying is that all people are not necessarily equally good at certain tasks. And so there's a higher likelihood that the metrics that we're using are actually mapping back into some real difference between the way people are, the way people perform. And depending on what worldview you have, that changes the kind of metrics that you're going to use and the way in which you interpret the data. And then if you're trying to mitigate these issues, there's the issue of, do I try to mitigate bias in the data itself? So as we're collecting data, and I have this group of data from, let's say, groups of students, and I notice that I have very few data from urban students, I have lots of suburban data. At that point, do I try to equalize these groups so that I have more balanced set of data and look at the metrics ahead of time before I try to feed it into my algorithm, or do I do it as part of the model? You know, when I'm modeling it, do I try to mitigate for unwanted bias in the model itself? And those are two different ways of doing it, both of which can be effective, but there's always a cost when you're trying to adjust your findings. And here's just an array, just so you get a sense of how much is going on. For metrics, these are just some of the metrics that you can use to evaluate fairness. In fact, there's around 30 or so of these. And these are just a few. You know, statistical parity difference, equal opportunity difference, disparate impact, okay? And they're all measuring different things, and they're related to this idea of maybe group or individual fairness and what you want to actually measure. And in terms of mitigating the biases, I mean, there's a lot of machine learning engineers entering this field, and they're very smart and they're very prolific. And so they're coming up with all sorts of optimizations, pre-processing, post-processing, ways in which you can manipulate the data to get a result which is more fair, okay? And part of the issue is what is fair depends on who you are, and it also is going to depend on the context of how the algorithm is being used. And more recent work, even in the past month or so, people are also looking at what's the downstream effect of this. You know, what happens when you do this? What are the effects? So for instance, the thing that really started this was that there was ProPublica had an article that, and there's a recidivism algorithm, and it's used to predict whether somebody's going to reoffend after they're arrested. And it was found to be biased towards African Americans. And so there's a big piece, and this really kind of launched this whole field, which is fairness, accountability, and transparency in machine learning. And recent work has looked at it and realized that you also have to balance public safety, you know, and there's issues if you want to optimize the public safety. It turns out that you actually don't want to have these constraining algorithms, and that overall you can optimize fairness without affecting this. You have to go back a step and actually look at the data, as opposed to actually trying to manipulate the data during the process. Okay, so how are we doing on time? Okay. So what we did is we took continue with the case study a little bit. So what we did is we took the BERT of the word embeddings, and there's a new, what's called the equity evaluation corpus, which is a bunch of sentences which are templates where you essentially will insert you know, different names of different ethnicities, male versus female. It's a little bit limited at this point, but this is the state of the art, right? This just came out now, like a month ago. And so what we did is we took this and we actually applied our sentiment analysis. And so they have different emotions that are expressed in these templates, like joy. There's neutral sentences, where there's nothing there. Sadness, fear, and anger. And so this is a bar plot of our sentiment analysis for these different templates. And you can see that we're getting, in general, the right trend. Part of the problem is that what's plotted in the gray here is the standard deviation, and it's actually quite high. So even though on average, the sentiment analysis is doing pretty well, or at least behaving the way we want it to, it's actually pretty unstable. So those of you who care, you know, accuracy of 91%, precision and recall, but I won't go through those in detail. So then we looked at race and gender, and these are these are cutouts from a dashboard that what I do is I do the analysis and then I hand it off to the ethicist, and this is a dashboard where they can change things like I only want to look at all the female and for African American, let's say, and see how the variations in that, and so these are just cutouts from that. So here's neutral sentences, European versus African American. Currently, they only have that those two ethnicities in this corpus, so hopefully they'll be expanding. I mean, we're doing it ourselves, but they'll probably publish. So European and African American, it's doing all right. Okay, doing male versus female. I mean, there are variations, and if you look, you can always find one of these gaffes in here, where the sentences that we saw before will show up. But on average, this is doing much, much better than that first iteration that we had. Here are the variation. Here are different sentence templates. This is for joy. These are only sentences that include joy. You can't read them here, so my apologies. But what you can see is this is the sentiment value here, and this is the standard deviation here. And the thing is, these variations are not what you want to see, because these are all expressing the exact same emotion. They should have roughly the same sentiment, but they're varying. And in fact, there's another mitigation strategy, which we're reluctant to use because we're so high on deep learning at this point, is going back to good old-fashioned AI, where you're encoding rules, okay? Can a simpler system work? And in fact, there is a simpler system called VADER, which is Valence-Aware Dictionary and Sentiment Reasoner. And it literally is the old-fashioned AI, where they have rules. They have rules that they know that if I have not in front of a word, it's going to negate it. For instance, they know they assign positive words and negative words. They have neutral words. And so this does much, much better, in fact. This plain old, no deep anything about this. This plain old rule-based system works much better in this case. And if you look at the bar plot here, as there should be for all sentences that include joy, there's no variation. And the standard deviation among each one is very, very low. It works very well. But as we know, we can't encode rules for everything. So part of the work that we're trying to do at BABL in terms of research and development is how do we marry this? How do we have deep learning inputs built in sort of a semantic representation background, where essentially we have rules, we have relationships that we've learned, just like our brain does. We have relationships between entities that we've learned. The inputs are coming through deep learning, like object recognition, natural language processing, but they're put into a context of a model that we have for our world. And that's why humans are so good at, squirrels can detect acorns really, really well. So can we, but we have a context for these things. That's what our brain is good for. So what we're trying to do is marry these two things, because this doesn't scale when we have new problems. It works really well for this, but it doesn't scale. So somehow we need to find a way to fix it. So here's another example. My last thing I'll talk about is it hasn't gone away, because Google, this is just recently, November 27th, Google basically is not going to use he or she gendered pronouns in their smart compose. Okay, rightly so, because it couldn't solve this problem. They have this state-of-the-art natural language processing system. It's called BERT right now, but the problem is it still relies on these embeddings, and it's encoding our biases in natural language. They couldn't solve the problem, or they have yet to solve the problem. So they've opted for the safe bet. It's not going to use gendered pronouns. So I'm going to meet my accountant, and he or she, right? And they're going to just avoid that. It won't fill that in for you. And they're worried about these gaffes. I mean, that's a problem. Okay, so I mean, the takeaway points really are that I would say that all data is biased. I'm talking about natural language processing. All data is biased. We count on it in order for our machine learning algorithms to work. What we want to be cognizant of is the unwanted human bias. It's a solvable problem. We can do this, and I think this is a good thing. As much as the press has become very bad recently, I think this is unearthing a lot of things that we need to deal with. And I think we're smart as a society, we can fix this. So all data is bad, or has biases, is not bad. But if we focus on putting people first, right? If that's our main focus about profits or anything else, then ACT doesn't have to worry about that in the sense that you're a nonprofit organization and you've already got this mindset. But putting people first. And I think that once we start doing that, we're going to really have a hope of trying to tackle some of these really important issues and not trip along the way. All right, thank you very much. Appreciate the time.
Okay, so I was really interested to hear your point about, well, even in the best cases, our algorithms might be biased because the human language underlying it is biased. And then that got me thinking, well, if that's true, then even these various mitigation strategies that you had up in the array of various things you could do to try to fix that, will those just become themselves artificial in a way that they no longer reflect the way people use the words themselves, and so they look like they get the right results because they, treat, men and women equally, or et cetera. But out in the world, people aren't like that. Yeah. Out in the world, people are biased, that it's sort of, we're cleaning up all of the stuff on the computer so that the computer isn't biased, but then the results don't map onto the real stuff, maybe.
Yes.
So it's not so much a question, but just, I really like that point that the data that the algorithms are based on might itself be inherently biased, namely natural language.
Yeah, I mean, it's totally fascinating. I mean, this is a tool. So we're partnering with some business ethicists, that do consulting for large corporations. And one way you can imagine using this, for instance, let's say I take all of the training data, as training data, I take all of the documents, training documents for a particular corporation, right, all of the language, all the presentations that they've used, and analyze in a similar way the corporate language, the corporate, what kind of words are being used in a corporation, and what do they map onto, what kind of context are they being used. It's a really interesting investigative tool. Unfortunately, it takes a lot of data, so it's hard to do. But in theory, this idea that we can use it to unearth what's really going on is good. And your point about these patches, right? And so in some sense, there is a worry that we're imposing our own bias by forcing certain results. Yes, yes, but this is where context matters. When you have an output which affects somebody's life, right? And so then the idea is, nobody ever strives for, if I'm a recruiter, it's not like I say, okay, this person is better than that person, right? This is like affirmative action. This person is better than that person, let's say, objectively is better. But I can't use that because I need to hire this person, right? That's a complaint people might have. But the idea is we have, as a society, this overarching ideal, right? And it's not how society works. But it doesn't mean we can't impose this ideal on the way we actually operate. What actually happens is that person had a lot of benefits along the way. The reason that they are better, it might be that they didn't, but on average, the reason that they might appear better is because this other person was disadvantaged. We know that because we have a very sophisticated model of how our society works and the problems our society has. So I think that we can do both. We can really analyze how things actually work, and we want to do that as deeply as possible, uncover exactly what's going on with all of these, and that's part of the fun, really digging in. And then you say, I have this ideal, I have this utopia that I want, and I have these values that society has. How can I make sure that those values are adhered to in cases where people's lives are affected? And that's the whole, that's the holy grail, figuring that out. But it's a good point.
Yeah, so one comment or question I had was around your use of Google News, or your sort of example from Google News, how that reflected bias. But one thing which I think is quite true and becoming even more true every day is that they're using algorithms to write news stories. And so this becomes a sort of self-fulfilling loop. And I think I recently read Cathy O'Neill, Weapons of Math Destruction, which if you haven't, I would highly recommend. And she talks about some of that too, that this can just feed on itself and become, perpetuate.
Yeah, that's exactly right. It's a self-fulfilling prophecy. I mean, this is happening all over the place. In law, people are using AI for law a lot, and not just for sentencing, but actually going through and looking at cases, right? And so one worry is that the way law evolves with society is that judges and juries are taking law into context of our current situation, our evolving society. What happens when you start locking in the decisions based on past performances or past instances, and essentially you can't evolve from that? I mean, ideally, we're smart enough we can come up with algorithms that do evolve based on societal context, but it's not obvious how we do that when you have these. So it's a really good point. I mean, it locks in these and perpetuates. It's a self-fulfilling prophecy, and that's really the danger. That's the FHA example. That's hard to get out of when you set up a system and you can do it at scale that affects a huge number of people. So that's a really, really good point.
I think we have
Shea, this is Alina, if I may.
Yes.
Hello.
Hello.
Thank you so much. Very nice presentation. I really enjoyed it. I want primarily to make a few comments about how we look at fairness in our work. And I'm making that primarily because you make those distinctions between two different worldviews. In our work, we do accept that there are differences at individual and group level in whatever we measure. However, we want to make sure that our tools are unbiased. So we look at conditional results. So given the ability that the person has, does that person have a fair chance of responding correctly? So it's not that we do not accept differences, it's just that we don't want those differences to corroborate with our instruments. So that's one comment I wanted to make. The second comment I would like to make is, and I agree with you on that, it does matter what is the purpose of the algorithm and what are the consequences of the use of that algorithm, because the same tool may have different features for different purposes, and some might matter more than others. So definitely I agree with you on that. So, but thank you. These were my 2 comments for this.
No, thank you very much. And in fact, I mean, I've read some of your papers, and you know, I definitely I like the idea. Essentially, if I'm getting them correct, you have these constructs, right? The things that you're trying to measure, and what you are trying to avoid are factors that are independent of that construct entering into the evaluation. Is that correct?
Correct. Exactly.
Yeah. Thank you.
So this is Saad. Hey, Shea, can you hear me?
Yes, yes.
Okay. Great talk, right? So one of the very interesting ideas that I've come across in the last couple of years in the machine learning community to address, you know, these bias and data skew issues is this notion that an algorithm and a machine learning algorithm should not be able, when they make a decision about an individual, that decision should not reveal anything as far as their gender, their ethnic background, their age, or what have you, beyond what is literally, you know, obvious in the data. Like, hey, you know, you're filling in a form and you know, put in your gender or your ethnic background, that kind of thing. So, I mean, which is an interesting way to look at this whole problem, rather than going by the data itself and say, you know, are there skews over there? You look at the end result, and actually, if there is some way that the result is correlated with those biases, then you know there's a problem. It's like an interesting sort of check on it in a very compartmentalized way. So I'm wondering if you guys, when you're thinking about sort of structuring this problem, in sort of auditing or figuring out a way that AI algorithms are not really biased, and is that an idea that you guys have explored?
Yes, I mean, that's a really good point. And in fact, I mean, it's one of the primary ideas. The reason being that a big problem is that these algorithms are written and are protected by intellectual property rights. So one of the primary tools that we foresee having are black box methods, where we essentially feed things in and look at the result, independent of what's going on under the hood, so to speak. And so a lot of what we've been working on are looking for these correlations of the end result on what we put in versus what we get out. And so that's, in reality, that's one of the primary mechanisms. Because even for a very basic neural network, we can't actually peer under the hood in any meaningful way. I mean, work is people are trying to do that, but so far, they're very opaque. Even a simple neural network, which is like one layer, you know, what do those layers mean, right? And so we're actually doing that, and it's a good point. And there are ways of doing that, and there are ways of making an algorithm effectively transparent, is the term I'll use, where you know, if I know when I put something in exactly what is going to come out, and I know all the statistical properties based on the sample that I put in versus what comes out. If I can sample the entire space of inputs, and I can look at all of the outputs, right? And I can find the statistics, and they're well correlated statistics, then one might say that I know almost everything about that algorithm. Right? There might be something going on in the inside that you might say is unfair, let's say. And people do talk about that. But if the inputs and outputs are well known and they are all fair and uncorrelated with things like gender or race, then who's to say that the fact that something went out under the hood, went wrong under the hood, so to speak, I feel okay with that. I think that effective transparency is almost as good as total transparency.
Right. So, I mean, I would highly recommend this work from Hart et al. I think it's 2016.
Yep.
Folks out of DeepMind, Google. The very interesting thing about it is that it's really designed so it propagates backwards in the machine learning sort of training cycle itself. I mean, their work is around how do you make sure, as you're training and building the algorithms, that it would ultimately need that sort of a test in the end, that it's the decisions that it's making do not reveal anything about a particular individual beyond just a literal data. So just something to add to, you know, as you explore. It's a very interesting topic. Thank you.
Yeah, thank you. Thank you. That's.
I have one last question.
Yeah.
Do you think that there is an ethical argument made based on the state of the art that people that are subject to the algorithm, like me, for example, where I'm taking a test and it's regular, that I should be able to opt out? That is, if this system is not refined enough, that I shouldn't have to be subject to it. Or do you think that ship is already sailed?
I have a feeling it's probably already sailed. I mean, in the context of, if you're talking about an
I'll repeat the question, please.
Oh yeah, I'm sorry.
Here.
So the question was, should there be the possibility for the subject, let's say in a testing scenario, to opt out of some automated testing? And yeah, well, I mean, Europe now has the general data protection regulation, which allows people to opt out of a lot of things online, including having their data saved. They have the ability to go in and edit what's being kept and make revisions and things. There are some cases, like in the cases of testing, for instance, which I think that probably would be really problematic in the sense that then, you know, the whole idea is that it's uniformly applied to everybody. And then if you start having opting out of that, that takes away the power of that. But there are a lot of scenarios, I think, where you can have this ability to opt out. There has to be some empowerment for the person who's subject to the algorithm. And so there needs to be space for that, especially when you know, your life is going to be changed by the outcome of this algorithm. You should have some recourse for either challenging it or opting out of it. And it's going to be a case-by-case basis. I think it's going to be a hard problem because it's going to be all over the place, that we're going to be assessed or rated in this way. And so in certain cases, it's really going to matter. In other cases, we could probably be able to opt out.
All right. We're a little bit over time, so thank you. And,
thank you.
thank our speaker.
Thank you.